Dear students, welcome to our class on JRF SRF Net 2022 Agricultural Meteorology Advances 2 at PG and Ph.D level. Agricultural meteorology students are expected to learn the fluxes of momentum, flux of mass, flux of heat, that is the energy, under neutral conditions and non-neutral conditions. So exactly what we need for agricultural meteorological purposes, that much only we try to understand, particularly from your examination point of view, some bits simultaneously we learn. So the purpose of today's class is in continuation of Advances 1, where we made a small beginning to understand the fluxes. In this class, we try to understand these fluxes, momentum flux, okay, mass flux and heat flux. Now, see, as agriculture meteorologists, our responsibility is to help the farmers. How we can help the farmers by adopting, by enlightening the farmers in micro meteorological techniques. In that, these fluxes are very much useful to you to understand the science at the micro level. So basically, Newton's law of viscosity, explains the moment of flux, the fluid flow. Fluids are both air and water. So fluid, by definition, by physical definition, is the fluid is the one which takes the shape of the container. That means if I put some air in this hand, it takes the shape of the hand. If I put the hands closed like this, it takes the shape of this particular shape. Similarly, water takes the shape, if I keep it here, and if I keep it here, water shape, this shape. So the fluid properties, basically, when you put them in a container, they take the shape of the container, okay, whether it is a glass, whether it is a tumbler, whether it is some other container, okay, right. Here, the Newton's law of viscosity. What is viscosity? Basically, as far as viscosity is concerned, some bits we try to understand, then let us understand some practicality of it. The resistance of a fluid to flow is known as viscosity. If we are giving irrigation to a paddy field, we allow the water to go into the paddy field through different techniques of irrigations, whether it is drip irrigation, whether it is sprinkler irrigation, whether it is a check basin irrigation, or whether it is flooded irrigation. There, the Newton's law applies. So the resistance of a fluid to flow is known as you can say viscosity. Okay, now, so this may come in the form of a bit. Similarly, what is the stress? Viscosity into rate of flow is called as stress. What is exactly the viscosity? Stress into time. Viscosity, okay, it offers some sort of stress or resistance. The fluid, for its flow, offers some sort of resistance. Either it may be surface or it may be some other, okay, material, physical material. Now, some most important points as far as Newton's law of viscosity I would like to share with you. Number one, all fluids have viscosity. Even though these are the fundamentals, we, the agriculture meteorologist, main objective is to help the farmer by modifying the microclimate. Okay, particularly my philosophy is that climate change is inevitable. It is the defining issue of our generation, the younger generation. Okay, now climate change, how to counter, how to combat the climate change negative effects. There, what I strongly believed, okay, is applying micrometeorological techniques. In those techniques, these are really useful. Now, all fluids have viscosity. Fluids are made of many molecules. Fluids are made of many molecules. All fluids have viscosity. What is viscosity? The resistance of a fluid to flow is known as viscosity. Now, the more the resistance, the higher the viscosity. The more the resistance, the higher the viscosity. What is it? I will explain to you after half minute. Now, water is much less in viscosity than oil. Water is much less in viscosity than any oil. Now, see, if you allow a boat to move on a water simultaneously on a oil. So the boat moves freely, quickly, with more speed on water as compared to oil, because oil has more viscosity. That means it offers a resistance as compared to water. Now, many fluids have a very strong temperature dependent viscosity. Many fluids have a temperature dependent viscosity. What exactly does it mean? If you go to purchase some snacks, okay, for you to eat, you have attended classes, you have gone for some exercises, you have gone for some playing of the game, wanted to have some snacks. Go to a shop where that person keeps some bowl in that some oil. When he puts fire to it, before putting the fire and after putting the fire, if you see, the viscosity is reduced when the viscosity of the oil is reduced when it is put to heating. So that means viscosity is dependent on temperature, simultaneously pressure also. That we discuss after half minute. So he puts the items in the oil and then he fries it, gives to you. If it is less viscous, there is an advantage for the person who is making those saviors or snacks, whatever you call it as. Now fluids puts stress or force that prevents the flow. If you take a glass full of water and a glass full of oil, and then if you put on the wall, the water flows quickly as compared to the oil. So that is again, that means water flows freely and quickly as compared to oil. Now, maybe honey also, inside honey or oil, they have more viscosity. The easier what is the inference for that? Let us talk of some inference. The easier a fluid moves, the lower the viscosity. The easier a fluid moves, the lower is the viscosity, and vice versa. Now, in high viscous fluids, strong forces of attraction exist. Strong forces of attraction exist in the high viscous fluids. When heated, attractive forces become less. That's why when you go to a snacks preparing shop to purchase, lesser the viscosity, better the entry of that particular oil into that particular savior, so that easy for preparation of it, easy for tasting of it rather. Now, the different magnitudes of relative movements. Relative, what is, in other words, in certain bits that you get in the Meteorology advanced bits, 20 bits will be on the advanced. The things that we are discussing in the class, helps you a lot in understanding those bits. That's why even though these are advanced class, no doubt, advanced class. Here in the advanced classes, some fundamentals with reference to inferences I am discussing with you. Here, very important thing is viscosity. Sometimes in the questions comes as a relative movement. The relative movement. Those words will give senior professors when setting the paper in deciding the grades. In deciding your ranking. Such questions. In such questions, relative movement they keep it. They never put the word viscosity. That's why that also you should understand. More viscosity means strong forces of attraction. Less viscosity means weak forces of attraction. Now, another few more bits with reference to Newton's law. Okay, I would like to discuss with you. Pressure and temperature are also considered when talking either viscosity or Newton's law. Pressure and temperature. Now, if for first situation, if viscosity does not change with pressure, if viscosity does not change with pressure, it is called Newtonian fluid. It is called a Newtonian fluid. If viscosity changes, viscosity means the stress changes, as temperature changes, it is known as non-Newtonian fluid. If it is viscosity does not change, with pressure, it is called Newtonian fluid. Similarly, if viscosity does change, as the temperature changes, it is known as non-Newtonian fluid. So that is the relation between pressure and temperature with reference to viscosity. Viscosity is also related to density of a fluid. What is the density? This much of mass in a cubic meter. That is the density. Mass in cubic meters. Okay, that's what. So it also changes with density. Viscosity is usually measured in, of course, Pascal seconds. Okay, Pascal seconds, which is kilogram per meter per second. That's what we call it as a measure of force equaling 1 kilogram per meter per second. Viscosity is usually measured in Pascal second. So these are the basis for our discussion for advances too. Now let us talk of Newton's law of viscosity at from your examination point of view. Okay, here they see shear stress is the word. Please note that important. Shear stress. Shear stress is equal to dynamic viscosity, which is related to kinematic viscosity. Rho v we call it as. Newton's law of viscosity defines. The relation between shear stress and shear rate of fluid subjected to a mechanical stress. Twice I read for your academic interest and benefit. Newton's law of viscosity defines the relation between shear stress and shear rate of fluid. Shear stress, shear rate of fluid subjected to a mechanical stress. Okay, now the ratio of shear stress to shear rate is a constant. The ratio of shear stress to shear rate is a constant for a given temperature and pressure and is defined as the viscosity or coefficient of viscosity. What is the coefficient of viscosity? Coefficient of viscosity is defined as the ratio of shear stress to shear rate, which is a constant. That's what we call it as the coefficient of viscosity. Now, the Newton's law of viscosity states that shear stress in a flowing fluid, is directly proportional to velocity gradient. That's what we call it as the rate of shear stress. So, momentum flux. Now, here, Newton's law of viscosity, fluid flow, it explains the momentum flux. The process is momentum flux is explained by Newton's law of viscosity. Now, what is momentum flux? It is the transport of momentum. Momentum flux, FLUX. Flux means flow. Momentum flux is the transport of momentum that acts in a direction perpendicular to the direction of the fluid flow. It is considered as the rate of change of horizontal momentum which is moving across a unit area equal to unit force per unit area. Momentum flux can also be generated by gravitational waves. See, please note very interesting thing. Momentum flux. Momentum flux means fluid flux. Flux means flow from one concentration to high concentration, one rate to other rate. Okay, these are all the things that are involved in the momentum flux. Momentum flux is the transport of momentum, transport of momentum that acts in a direction perpendicular to the direction of the fluid flow. Okay, it acts in the perpendicular direction to the fluid flow. That is momentum flux. Now, let us try to understand 1 minute each on mass flux and heat flux. Now, here, so what is mass flux? Mass flux is explained by Fick's law. Fick's law, F-I-C-K-S, Fick's law of diffusion. That's why FL is equal to minus Ks ds by dz. That's what in the theory we discussed. Actually, the definition, Fick's law of diffusion states that the molar flux, okay, mass flux or the molar flux due to diffusion is proportional to the concentration gradient. Say, for example, I take a perfume. I just push the button of the container of the perfume. It goes from high pressure to low pressure. Okay, so here high concentration to lower concentration. In the room, a high concentration, if I keep something, a mango here, it gives the mango smell to me. If I keep a banana. So high concentration to lower concentration, the smell, that's what we call it as the diffusion. Fick's law of diffusion says that the molar flux due to diffusion is proportional to the concentration gradient. Where I kept banana or mango or perfume, there is high concentration. It flows to lower concentration. Now, this law describes the relationship between the rate of diffusion and some other factors. What are the factors? What is the area? Okay, if more area is there, you would find the smell. Lesser area, you would find the smell. Second thing is, it depends on the concentration difference. It is inversely proportional to the thickness of the membrane. The rate of diffusion is proportional to surface area and concentration difference. Surface area and concentration difference are the first factors. It is inversely proportional to the thickness of the membrane. If you wanted to see from a membrane, from here to here, if you keep a membrane, okay, thickness of the membrane, concentration difference, temperature, area, these are all the factors. Last half minute of today's class, we try to discuss once again the heat flux. Heat is the energy flux. It is explained by Fourier's law, F-O-U-R-I-E-R-S, Fourier's law of heat. Okay, diffusion. Fourier's law of diffusion. Otherwise, see, there are different words that are used in your bits that you should be very careful with reference to heat flow. It is heat flow is mentioned in your bits like this. This is my experience. Heat flux, thermal flux, heat flux density, heat flow density, heat flow rate, okay, intensity, heat flow rate intensity. Once again, for your academic interest title, in the bits, heat flux, Fourier's law of thermal diffusivity is mentioned in these words. Heat flux, thermal flux, heat flux density, heat flow density, heat flow rate intensity. It is defined as a flow of energy per unit area per unit of time. It is a flow of energy per unit area, okay, per unit time. It has both direction and magnitude. That's why it is a vector quantity. Now, in some bits it may be given like this, when the rate of heat energy that passes through a surface is known as heat flux. Okay, that's what I would like to share with you. Now, to sum up with reference to heat flux, thermal conduction is the transfer of internal energy. See, heat flux we define, we explain in terms of thermal conduction. Conduction is one of the processes where there is no movement of the molecules, unlike convection. In the thermal conduction, what happens is collisions of particles and movement of electrons within a body will take place. Collisions and movement of the molecules in that conduction process take place. In the heat flux, the colliding particles, which include molecules, atoms, electrons, etc., etc., they transfer disorganized microscopic kinetic and potential energy, jointly known as internal energy. Okay, what is internal energy? A microscopic kinetic and potential energy. Microscopic kinetic and potential energy, which is in a rod of iron, for example. Atoms, electrons, molecules, whatnot, they disorderly take the heat flow. That's what is explained by Fourier's law. These are all useful to the agrometeorologists in energy balance equations. Rn net radiation is equal to latent heat flux plus sensible heat flux plus ground heat flux, and energy stored in the economic parts of a plant or plant growth in the biomass, both in the root as well as in the above the ground parts. So once again, I would like to impress upon you that the momentum flux, which is explained by Newton's law of viscosity, the fixed law of diffusion, where we explain the diffusion of water molecules. Say, for example, open water is, a lake is there. From the lake, water enters into that's what is the mass flux. Okay, momentum flux, Newton's law of viscosity, mass flux, fixed law of diffusion, and finally heat flux. It is explained by Fourier's law of thermal diffusivity, we call it as. So these are the basics in advances for applications to benefit the farmers. Thank you very much for your very patient hearing.